So just to round out setting up all of our primary key, foreign key relationships, I'm going to go ahead and take our loaner table primary key and link it to our loaner underscore ID column in loaner book. I'm going to stick with just the default constraint and relationship settings just for speed. Branches will connect to branch underscore ID, again with the branch ID being the primary key and then branch underscore ID being the foreign key. Book and book ID, again, primary key, foreign key relationship. So now that we've set all of those up, with saving these diagrams, that will actually update all of the database tables and build in the appropriate relationships. So we're going to go ahead and hit yes to that, and that will then save those relationships into our actual database schemas. So now that we've got all those in place, let's kind of switch gears a little bit and talk about the importance of identifying indexes on our database tables. Now, an index is designed specifically for performance and to enable fast lookups. Every time you create a primary key on a table, you're essentially creating an index on that column, and that index is there for fast lookups. Databases go through one of two modes. They do index-based lookups, or they do what are called table scans. Index-based lookups are essentially that you put an index on a column, and then when you do a where clause where you're searching for specific rows that match that column data point. So for example, whenever you're looking for a branch that is in the state of Ohio, let's say, you would, if you have an index on there, it would actually have a collection of all the rows in the table that match the state of OH, and it would quickly return you back those rows. If you did not put an index on there, and let's say you had a million rows or a million branches in that table, then it would actually have to go through, and obviously the computers are fast, but still a million rows is a lot, and it would have to scan every row in the table and check, does this match OH? Does this match OH? Does this match OH? And go through that comparative process to check and see if each column, or I'm sorry, if each row had a state that was OH for Ohio. So indexes are a very big thing. And one of the things that they're especially important to make sure that you set up are indexes on your foreign keys, because half of a primary key foreign key relationship is that foreign key, and that does involve lookups. You may end up saying, I want to find all of the given books at a branch. Well, in order to do that, you would query branches, and you would join on branch book, and then you would join on books. And by doing that search of branch underscore ID as the foreign key to find all the associated book IDs, you would have to do a where clause on that branch ID. So putting indexes on your tables is really important in terms of getting performance. Now, setting up your indexes can be done in a number of different ways. One of the most common ways is, again, utilizing the database diagrams. You can right click on a column and you can go to indexes and keys, and this will bring up a list of all the indexes and keys for a given table. So you'll see here that there's a PK, or primary key index, that is already set up for branch books. And let's just kind of explore that primary key for a moment. We'll see here that there are two columns in our primary key, and these two columns are part of what is referred to as a clustered index, and that's made up of the branch ID and book ID. So these two values together have to be unique, and this is considered the primary key index. And this is a clustered index, which means that the data in our database will be sorted and actually be presented by default in our table based on that index. That's why it's often that we use the integer field with an identity column, because those identities are numbered automatically from top to bottom, or lowest to highest, so from 1 to X. So there's no need for the engine to have to resort the table. It automatically just sorts by the fact that the identity increases or increments one at a time. If we end up doing something where we're using, again, like social security numbers or some sort of product ID, the database engine will actually have to resort the table if we insert a new record at the bottom of the table that does not fall into the sort order appropriately. So it'll actually take that row and then move it somewhere else so that it sorts, from smallest to largest. So this all happens just by right-clicking and choosing primary key. This index gets created. So that's a pretty nice thing. And because our foreign key is our primary key in this instance, there's no need for us to actually index these primary key fields. So let's go to one where we do need an index, author ID. So we'll right-click on books and we'll choose indexes and keys again. And we'll see here that the primary key index is on the ID column. It is unique, it is a primary key index, and it is clustered. So our ID number will auto-increment or auto-number from smallest to largest. So we want to go ahead and add another index. You'll see that it called it IDX books. We can give that a more unique name if we choose. And we do that down here, and we're going to call it IDX underscore books underscore author underscore ID. And then back at the top here, we're going to choose a column. And the column that we're going to choose is going to be the author ID. We can add multiple columns to the index, and we'll talk about compound indexes or multi-column indexes a little later. But we do have the ability to add an additional column, but for now we'll just go author ID. It's not unique, so we can have multiple books with the same author ID, and that's kind of by design. Under index types, or under types of indexes, we can have a unique key or an index, and this is just going to be a straight index, no unique keys. This will not be a clustered index, we already have one on our primary key. And then we have some control over things like data space specifications, fill specifications, which we won't get into right now. But that has to do with architecture from a software hardware kind of standpoint of where data is stored and how it's managed. So by adding that new IX, we can go ahead and just hit close, and then when we save our diagram, that will update books with that new index, and we'll hit yes. So now if we right click, we can see the indexes and say, hey, that author ID now has an index in place. So what are other common ones? Well, common is a relative term, and really what it boils down to is what data would you be doing lookups on? So when you talk about things like authors, you'll probably want to be looking up an author by last name. So we can right click on the authors table and go to indexes, and we can say add, and we can add an index on the last name column, because often you're searching for someone by last name, and then we can add a secondary column for first name. And the way that this works is that by selecting two columns, the index only kicks in if you search on both columns or you search on the first column first. So let me hit OK here, and then let me explain it, because it's easier to read this way. So if you do a search on author where you're searching by the name and you're filtering by the name, you must filter by last name in order for this index to work. So commonly if you're searching by author, you'll be searching by last name, so that's really not a problem. But if you go in and you search by last name and first name, then this index actually becomes even more powerful because it has index references for both last name and first name. So you'll get the power and the strength of having both columns indexed. The challenge is that while last name and first name are in this index, if you only search by first name, then you cause a table scan to occur, and that's because you have to first search by last name in order to get the advantage, the performance boost of the first name index. You have to do last name in order to get first name. If you just do first name, then you end up performing a table scan and you're checking all of it. Or you have to add another index on just first name. Now indexes do have a cost. They're not free. Every time you create an index, that index then has to be kept and stored and then updated every time you do an insert or an update to your database. So it's not something that you just want to index everything, because there is a storage cost and a potential performance hit in terms of inserts and updates to your database if you have too many indexes. But having the right ones for the right reasons really can be a huge performance gain. Now, the last little thing I do want to talk about is where you can actually include additional columns with your indexes. So we talked about how indexes give you a big performance boost in your searching of data, but you can even get a bigger boost if you have specific columns that often get returned back in your select statements. So with a standard index, what happens is that you search on that index then becomes nothing more than a row pointer that tells you, hey, this is the row that you need to go to get the data that you're looking for. So if we were to be searching on book and we search by ID, we wouldn't actually get back all of the data such as title, author ID, ISBN, page count, and so forth. We would only get back the book ID, and then we'd have to go to that row and extract the data, so it becomes multiple steps. And when you're looking at hundreds or thousands or even potentially millions of records that you're filtering through, that performance becomes huge as things get bigger in scale. So to again combat that, you can go into your Object Explorer tables, and I'm going to go into authors, and we'll just keep playing with the same index. So under authors, last name, first name, which I named it incorrectly. See if I can correct that real fast. There's the last name, first name. All right, so I'll double click on that. That brings up actually a index properties dialog, which is much more sophisticated than what we had just through the diagram. And what we can see here is we can see that we have table name, index type, and we have control over index columns and included columns. We also have options here, so we can go through and identify a lot of the different options. We have more of the details about the storage, filter expressions, fragmentation. Again, this has to do with storage and performance. And then you have some extended properties around collation and things like that. Fragmentation, just if you're curious, I'm not going to get into it right now, but it's a very interesting concept of being able to take your data and actually break it and kind of splinter it across multiple physical storage spaces. And the advantage there is that if you have a lot of high performance tasks where you're querying a lot of data quickly and you need to have good performance, you want to distribute the work across multiple locations physically, so that you can get the most bang for your buck. So imagine you've got a whole array of SSDs and you really need to make sure that your search times are really fast. You can actually use the fragmentation functionality to ensure that you're spreading that data as wide as possible so that you can get the most consistent throughput through this process of what you're working to do. So it's pretty cool little steps and a lot of performance tuning and things like that, but those are much more advanced concepts. Alright, so under general, we have the index columns, which we set before, which are our first name and last name. And then we have the included columns. Included columns are columns that basically come along for the ride. They get stored in the index when the index is built and rebuilt. So let's say that often we search on last name, first name, and we always end up needing back ID and birth date. For some reason, birth date's always coming up. It's always a thing, and we want to save ourselves the trip back. So we add those to the included columns. So then whenever we do a search that utilizes this index, if we search on last name and say give me back all the Smiths, the actual result set that comes back will be Smiths. We'll get the first name back because it's part of that index, but we'll also then get back the ID and birth date. So if we have select ID, birth date from authors where last name equals Smith, that'll take practically no time to get back all of that data. Now, that being said, all of that data then has to be stored in the index in order for it to actually function that way. So you indirectly end up duplicating a lot of your data the more columns that you include in your index. So it's something to kind of, again, weigh in terms of performance and storage and things of that nature. Because it's kind of duplicated, when you do an insert of a new record into a table, that record gets inserted into the main table, and then it also gets inserted into the index. So that becomes, again, 2 writes that has to occur instead of just 1, and depending on the number of columns that you include in your index, that's the number of columns that have to be written. So if you multiply that out in large scale and you're running transactions of hundreds of thousands or thousands of millions of transactions per minute, per hour, per day, maybe per second, I don't know, that's a big performance hit. So things to definitely keep in mind. So go ahead and hit OK there. That index is now updated, and we now have a high performance index on our author lookup. So when we search for authors by last name, we're getting those records back fast.